Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. In this video, I will do a demonstration on configuring VLANs. This is Packet Tracer 3.2.1.7. Okay, so if I access my Packet Tracer files, so there we go, configuring VLANs. Okay, now the Packet Tracer finished loading. I'll cancel the user profile, access the Packet Tracer activity and see what we have to do there. So I'm going to maximize this. Okay, configuring VLANs. So we have 6 PCs here. The objectives for this activity is to verify the default VLAN configuration. Part 2 is we configure VLANs, and then part 3 assign a VLAN to a port. So, with little background, VLANs are helpful in the administration of logical groups, allowing members of a group to be easily moved, changed, or added. This activity focuses on creating and naming VLANs and assigning access ports to a specific VLAN. So, what are VLANs? Virtual Local Area Network. Now, by default, all the PCs are in same VLAN, VLAN 1. Now, when one PC sends a broadcast, every PC will hear that broadcast. And now that's not very good, and as well as the security reasons, every PC will be able to communicate to any other PC on the same VLAN. For that reason, to reduce a broadcast and to increase the security, we create extra VLANs like a virtual local area networks, another VLANs, and then we take the ports from VLAN 1 and we add them to the specific VLAN. For example, we create VLAN 10 for sales, VLAN 20 for marketing, and whatever the company requires. So you create the VLANs for department, for the groups. Okay, so part 1 says view the default VLAN configuration. Step 1, if I go scroll a little bit up, down, and then step 1, display the current VLAN. On switch 1, issue the command to display all VLANs configured. By default, all interfaces are assigned to VLAN 1. Absolutely. So we go to switch 1, find the switch 1 here. Okay, so CLI of the switch 1. Okay, let me just fix the size there a little bit. That's better. Okay, so we are now in the user mode, enable, and then show VLAN. We do show VLAN brief really, but let's just do show VLAN first. Now we can see that by default we have VLAN 1, VLAN 1002, 1003 here, 1004 and 1005. Now VLAN 1 is a default VLAN. This VLAN you can't change the name, you can't delete it, and by default all the ports they belong to VLAN 1. You can see all the ports on the switch from 1 to 24 and gigabit 1 and gigabit 2, they belong to VLAN 1. That's our default VLAN. And then we have 4 other VLANs. They are for backward compatibility, but they are unsupported. As you can see, it says unsupported. We have FIDI default, token ring, FIDI net default, and token ring net default. These are 4 VLANs, but it doesn't support them. So by default we have 5 VLANs, 1 active and supported, and 4 active but unsupported. And all our ports are in VLAN 1 by default. So if one port sends a broadcast message, everybody else will get that broadcast message. If PC1, for example, PC connected to Fast Ethernet 01, it's sales team. And PC connected to Fast Ethernet 010, for example, is financial PC. These PCs will be able to communicate with this PC, and that's a security risk. You don't want the PCs to be able to communicate to another PC in another department without going through a layer 3 device. So we can check, for example, we can restrict them with access list, and we can kind of control a bit more. Okay, then down here we have other like a remote span, primary, secondary, and so on. We don't configure any of these in CCNA. We will configure them on CCNP. What we usually do, instead of just saying show VLAN, we say show VLAN brief. And that will show you like a brief description of all VLANs. So as we can see, we have VLAN 1, we set default VLAN, and all the ports are in VLAN 1. Okay, that was issue the command to display all VLANs configured. By default, all interfaces are assigned to VLAN 1, which is true. And in step 2, verify connectivity between PCs on the same network. Notice that each PC can ping other PCs that share the same network. PC1 can ping PC4, PC2 can ping PC5, PC3 can ping PC6. Okay, so let's try that. PC1 can it ping PC4? We can just do like this envelope, or we can actually go to the PC1, open the PC1, go to desktop, and ping PC4. So ping, and then I'm just going to find out the IP address of PC4. The IP address of PC4 is 172.17.10.24. Okay, 172.17.10.24. And yep, we can ping that. That's no problem at all. Okay, so we go to PC2. Can it ping PC5? So have a look at that. We go to PC2, go to desktop, and type ping, and we're just going to find PC5's IP address, which is 172.17.20.25. 172.17.20.25. And yep, we can ping that as well. We have a reply. Excellent. Can we ping, what's the next? PC3, can I ping PC6? So you go PC3, it's here, and we're pinging PC6. Okay, so open PC3, ping, and the IP address of PC6 was 172.17.30.26. 172.17.30.26. Yep, we can ping that as well. Excellent. So all the PCs, well, if we look, what this has like PC1 can ping PC4 because they are in the same network. 172.17.10 and 172.17.10 here, they are exactly the same network. So this is okay. We can't really change anything there. But 172.17.10, they are sharing the network. Can PC1 ping PC5? Okay, let's go to PC1. If I just move this screen a little bit, I can see the PC5 IP address. So let's say ping 172.17.20.25. This fails. Why? Okay, I'm going to stop this ping. Just don't rush. First ping will fail. It's ARP. But when you fail, the second ping fails, then definitely there's a problem there. Control C to break this. If I do ipconfig, I can see that it's 255.255.255 my subnet mask, which means my network is 172.17.10. And the PC5, I presume the MAC address subnet mask is going to be the same. But the IP address, see, the network says 172.17.20. So for these two PCs to talk to each other, they need layer 3 device. So they're not going to be able to ping. Let's see if PC1 can ping PC6, which it shouldn't, because this one it says 172.17.30 something is the network ID. So let's try ping 172.17.30.26, and it's going to fail. The reason is the PC can ping the other PC as long as it is on the same network and in same VLAN as well. Okay. As we can see, the pings are failing. Right, let's move on. Now, what benefits will configuration VLAN provide to the current configuration? So the benefits will be like the primary benefit for using VLAN will be security. Then we have a cost reduction. We have a higher performance, broadcast storm mitigation, and improved IT staff efficiency, and simpler project and application management. For example, one of the benefits will be the broadcast storms. If one PC sends too many broadcasts, the other PCs, they're just gonna start processing this broadcast messages. The next one, we move on to part 2, configure VLANs. Step 1, create and name VLANs on S1. Create the following VLANs. Names are case sensitive, so we need to create 4 VLANs here. So we go to switch 1 again. So if I open switch 1, S1 here. Okay, I need to go from the privilege mode to global configuration mode. Configure terminal. And then to create the VLANs, it's very easy. Just say, okay, we need VLAN 10. So we type VLAN 10. That's it. We have created. We don't have to give the name. Name was optional, but for us to manage it easier, we will give a name. So name, faculty, staff. That's our name for that VLAN. Okay, so we don't have to do exit and create a new VLAN. We can just continue there, but just for the clarity, I'll do an exit. VLAN 20, name students. Exit. Then VLAN 30, name guest, and then default. I have to warn you, if you follow this on the packet tracer, you have to create the names exactly the same. Is a capital S, you have to put capital S. Lowercase s, it will not be counted towards your completion. So you have to put exactly the way it is there, is written. Okay, so next one we're going to create is VLAN 99, name management. Okay, so management and native. Exit. Okay, we are done. So verify the VLAN configuration. Which command will only display the VLAN name, status, and associated ports on the switchboard. So which command? Show VLAN brief. Now we move on to step 3. It says create the VLANs on switch 2 and switch 3. Using the same commands from step 1, create and name the same VLANs on switch 2 and switch 3. So let me just close this. Select switch 2, CLI. Yeah. Okay. So on switch 2, enable, configure terminal. So we go into global configuration mode. VLAN 10, name, faculty, /staff, exit, and VLAN 20, name student, exit. I don't have to do exit, I'm just doing it for clarity, but you can just continue. And VLAN 30, name guest, default, and then VLAN 99, name management and native. Okay, excellent. Now we completed 40 out of 90, so that's great. So okay, we're gonna go to switch 3 now and do the same configuration. So go to CLI, expand this a little bit. There we go. Okay, so we are in user mode, enable, configure terminal, and then VLAN 10, name faculty, staff, VLAN 20, name student, VLAN 30, name guest, default, and then VLAN 99, name management and native. Okay, excellent. Now we did this on all 3 switches. If we left it to default, and if they have the VTP domain name set to same, if they share the VTP domain name, these VLANs they will be propagated from one switch to another. You didn't have to do this on each switch. Anyway, if you have to do it, the best way to do it is to go to and configure all these in the notepad, and then just copy and paste. Okay, so we did the VLANs on same as in step 1 we did for switch 2 and 3, and we need to verify the VLAN configuration. So in switch 3, show VLAN brief. Yep, the VLANs are there. Excellent. If I go to switch 2 and to go to privilege mode, show VLAN brief. Okay, so I got all my 4 created VLANs there. Now we need to assign ports to VLAN. So assign a VLAN to active ports on switch 2. So if we go to switch 2, which we are now, assign the VLANs to the active port. S3 uses the same VLAN access ports assigned as S2. Okay. On the step 2, previously PCs that share the same network could ping each other successfully. Try pinging between PC1 and PC4, although the switch ports are assigned to the appropriate VLANs where the ping is successful. Okay, let's just not move forward. 1 second, let's go back to step 2. It said assign the VLANs to active ports on switch 3. Okay, so if we go back and check in our topology, this is our topology. So we see the switch 2 has got port F011 on VLAN 10, port FA018 in VLAN 20, F06 in VLAN 30, and switch 3 has got the same 11 on VLAN 10, 18 on VLAN 20, 6 on VLAN 30. So we go to switch 2 first. Switch 1 doesn't have any port to any VLANs, so go to switch 2 first. And if I just move this bit so we can see it. Okay, so global configuration mode, configure terminal, and then I will have to go to this port first. So it doesn't matter which port you go, but you have to go to interface commands. So all these commands will be on the interface. So let's go to FA011 first. Interface FA011. Then the command is to make, first we need to make the port as an access port. So switch port, mode access, and then switch port, access, VLAN 10. So port 11 is going to VLAN 10. Okay, let's confirm that very quickly. Show VLAN brief. So we can see the port 11 has moved to VLAN 10. Excellent. So it's not there anymore. One port can belong to only one VLAN. So now we can go to next port, port 18. So configure terminal again. Let me repeat up arrow to repeat the command. Interface now 18. Press enter. Up arrow to repeat the commands. So the memory, switch port mode access, and then switch port access VLAN. This one is 20. And then I'll do exit for clarity. Interface FA06, which is this one, this interface here. Switch port mode access, switch port access VLAN 30. End. Okay, so if I do show VLAN brief, I can see VLAN port 11. Like we said, it's in VLAN 10, so that port is in VLAN 10. Port 18 is in VLAN 20, and port 6 is on VLAN 30. There we go. Okay, now we do the same commands on the switch 3. Now the best way to do it is open the notepad. So if I open the notepad, okay, let me just move this to increase the font a little bit so we can see it better. Easy configuration in the notepad is much easier. So let's do this configuration. So interface FA011, switch port, mode access, switch port access, VLAN 10. Right, now I can just copy these three and paste them, and again, right, let me just make a little gap so we can identify which port we're doing. Okay, this exclamation mark, they're not going to take effect on the router, so it's not going to give you a warning. So this is the interface 11, this is interface 18, so I'm going to change this to 18, and then change it to, this was to VLAN 20, and the interface 06 is going to go to VLAN 30. So there we go. I can just do like this, copy it and paste it on both of my switches. So highlight all of it, right click, copy. Now I'm going to go to switch 3 and paste it. So config T and just right click and paste. There we go. There's no any errors, everything's worked fine. So if I want to confirm this, I go to end and then show VLAN brief. I can see the same thing as in switch 2. So switch 3, we move to the same as switch 2. So the best way to do it in Notepad, it will speed up the configuration. Okay, next one. Let's see what it says. Verify previously PCs that share the same network ping each other successfully. Try pinging between PC 1 and 4. Okay, let's do that. Let's go to PC 1 and see when we ping PC 4 early, we could. So that's the IP address. Okay, let me just copy this. So I need to type it again and right click and paste it. Can we ping it now? No. Okay, the first ping again, anyway, just don't rush to presume that it's not working, since the first ping will be ARP. But definitely if you get request timeout 3 or more pings, definitely something wrong there. Okay, so it didn't work. What do you think it could be the reason? Before, it was working. PC1 could ping PC4. Now, PC1 cannot ping PC4, even though they are in same VLAN. Same network, same VLAN. Well, the problem is that this port here, between the two switches, is an access port. It should be a trunk port. So if you look here, G11, it says there G11, but it's actually G01. G11, but it's G01. It's an access port. If I say, I've got to switch 2, yeah, this switch here. So switch 2. And I'll do show VLAN brief again. You can see that G01 is an access port. It's on default VLAN 1. So if I say show interface trunk, there's no trunking happening. Or I can say show interface G01 switch port, and this tells me is dynamic auto administrative mode and is access. Really, this port between those two switches should be in the trunking. So to make this work, we have to make sure that this port between the switches are trunking. Okay, now the trunking is the next video, but I'm going to demonstrate to you. So let's run a continuous ping between PC1 and PC4. So ping, repeat the command. Now in the Windows it's like this, -T at the end, but on the packet tracer is a -T in front, if I remember. Yeah. Okay, so let's continue. This is continuous ping. So we're gonna make sure that this G01 port, this port here, between the two switches, G01, and this one is trunking. If I highlight just above the green, I can see there's G01. And if I highlight here, I can see there is G02. You can see that this is typing error. Okay, so let me go to that port, config T, interface, G01, switch port, mode, trunk. Okay, done. Now I have to go to switch 1 as well, do the same for both of the ports. So go to the switch 1, enable, config T, interface, G01, switch port, mode, trunk. Okay, and then the other port, G00, 00 was it? Or 02, sorry. Yep, switch port, mode, trunk. So you can see the port goes down and then comes back up. Okay, this port has gone green, so let's go back to our PC1. It's still timing out. Okay, let's wait a few more seconds until we do it on the switch, a third switch, so not rush things. Okay, so config T, interface, G002, switch port, mode, trunk. Okay. So now that these ports are trunking, we should have a replies, and yes, we do. Okay, so the only reason why we couldn't ping each other PC1 and PC4 is because there was no trunking, the ports that were not trunking, and we found that out, right? Let me just stop this ping because it's going to continue. Okay, doesn't matter, it's packet tracing. It's not going to hurt any bandwidth anyway. Okay, so the way we found that out, the port, you have to do show interface trunk to find out what interfaces are trunking. So at the moment on switch 1, 01 and 02 are trunking, right? Now show interface G01 switch port. It shows that administrative mode is trunk and operational mode is trunk. I think we ran this command on switch 2. Yeah, switch 2. So we look early on. It was an administrative mode, was dynamic auto, and it was working as an access port. It's not good to work in access port because between two switches we really want to be a trunk. So show interface G01 switch port, and we can see that administrative mode is trunk, operational mode is trunk. Excellent. So show interface trunk, and we can see the port is trunking. Excellent. Okay, let's just see what's our score. Did we achieve 100%? Yep, 90 out of 90. Excellent. So we can check the results. Need to minimize most of this stuff. Let's minimize. There we go. Okay. We have on VLAN 1, we created VLANs with the correct name. Now remember that if you're following along, the letters they matter. The uppercase, lowercase, they do matter. On the switch 2, we created the VLANs and then we assigned the ports to correct VLAN, and same for the switch 3. Okay, without extending this video any longer, thank you very much for watching the video. I'll show you on this demonstration how to configure VLAN, and a little bit we touched on the trunking between the two switches. Thank you very much and see you in next videos. Bye bye.